This is the first part of a two-part video. Heat capacity and specific heat. There's a lot of confusion surrounding these topics because while heat capacity and specific heat are closely related, they are not quite the same thing. It doesn't help that specific heat is often referred to as specific heat capacity. I personally prefer the name specific heat. That's what's in all my old textbooks. But the name specific heat capacity is all over the internet, so I guess we have to get used to it. It doesn't help that sloppy professors sometimes say heat capacity when what they really mean is specific heat capacity. So it's up to you to read their minds and figure out what they're really talking about. And I'll give you some pointers on that later on. Let's talk about heat capacity. Every object has a heat capacity. For example, this pen has a heat capacity. This phone has a heat capacity. Every solid, every liquid, every gas has a heat capacity. What I'm going to present here applies mainly to solids and liquids. The rules for gases are a little more complicated because you have to take pressure and volume into account. What I'll have to say will still be relevant to gases, it just won't be the complete picture. Let's just think of a simple example. Suppose we've got an object that has a heat capacity of 1,000 joules per degree Kelvin. What does that mean really? Well, this is just a conversion ratio that converts between joules and kelvins. You can think of the Kelvin unit as being essentially an energy unit, just like joules is an energy unit. And just like you can convert between units, you can convert from feet to meters or gallons to liters, you can convert between kelvins and joules. Now, heat capacity is a little more complicated than those other conversions because every object has its own conversion ratio. It's not quite so straightforward as that other stuff. Nevertheless, we can imagine you got an object that has a heat capacity of 1,000 joules per degree Kelvin. All that really means is if you add 1,000 joules of heat energy to the object, its temperature is going to increase by 1 degree Kelvin. If you add 2,000 joules, the temperature will increase by 2 degrees Kelvin. If you want to increase the temperature by 7.5 degrees Kelvin, then you're going to need to add 7,500 joules to that object. Of course, in the real world, we don't have nice round numbers, so you have to whip out your calculator to do these kind of calculations. And if you're going to do that, it's kind of nice to have a formula. So let's see if we can figure out a formula based on what we know here. Let's look at the units. You can get a joule if you take these heat capacity units, joules per degree Kelvin, and multiply by Kelvin degrees. Now, you don't actually have to use these exact units. Any energy unit will do. You can use ergs or foot-pounds or electron volts. Any temperature unit will suffice. You can use Fahrenheit degrees or Celsius. The actual number for the heat capacity will be different depending on what units you choose. You'd have to convert the units to figure out what the number is. But we like to stick with joules and kelvins, and that's what you're usually going to see. So if energy equals heat capacity times temperature, that suggests a formula that looks like that. Q is the variable we usually use for heat energy. There's C for heat capacity, and then there's delta T, which is the change in temperature. The temperature could go up, could go down, you can add heat, you can subtract heat, but there's your delta T. Now this is all fairly simple, but people naturally sometimes make things more complicated than they have to. Here's a bunch of other formulas that are all equivalent to what I just showed you. Any of these would be fair game, I suppose. And that's not all. People don't always use the letter Q for heat energy. You could use some other variable like E for energy or H for heat. People do that sometimes. I've seen people use the letter S for heat capacity. I don't know where that comes from. So the result is that you could be looking right at a formula for heat capacity and not even recognize it because it's in some unfamiliar form with unfamiliar variables. But you can keep it all straight if you just remember the units. Energy units divided by temperature units, and you're either multiplying by the heat capacity to convert from kelvins to joules, you're going to divide by the heat capacity to convert from joules to kelvins, and that's really all there is to it. In the next video, we'll talk about specific heat.